I am going to upload in the Canvas, hopefully sometime today, all of Unit 2 from last semester.
Okay.
So if there's something in 212, you're responsible for 212.
Yeah.
If there's something you don't understand, you can watch videos, there are videos in there, you can ask for it.
Okay, thanks.
Or you can come to office.
Okay.
Not yet. I needed somebody who was going to my courses. And until somebody does something, I thought I was the All right, here we go, friends. These are the same notes we had last time. These are not new. We are beginning. You guys already have these. We're beginning a new page of the notes, but we already have them. Okay. Quick review of the properties. We talked about these before. We've been using them. But a quick review. If we multiply numbers with the same base, then what do we do with the exponents? If we divide, then we subtract them. And if we have a negative exponent, what does that do? That would be 1 over b to the n. O, and then we have b to the m to the n. What do I do with those exponents? Alright, so that's old news. You guys, you've done that for years. Logarithms, you haven't done these for quite as long, but we have talked about this. If you take the logarithm of a product, we add the logs, and vice versa. So if you have a sum of logarithms, that can be combined into the logarithm of the product. This, of course, is dependent on the bases being the same. So if you're going to be combining these, they have to have the same base, whatever that base is. It can be anything, but it has to be the same. All right, how about for a quotient? Oops. For a quotient. Then that would be the log of the numerator minus the log of the denominator, right? These properties mimic the exponent properties. Division is subtraction, multiplication is addition, just like with the exponents. And then, if we're taking the logarithm of something to a power, that power becomes a coefficient. This is my very favorite thing about logarithms. That power becomes a coefficient, and then it makes it easy to solve equations. Okay? The other thing that is critical, and I know you already know it, but I'm going to write it down one more time. If we have the log base b of x equals y, we have a logarithmic statement like that, we can translate that, loop through it, into an equivalent exponential, and what would the exponential be? B to the y equals x, right? Okay. All right, let's bump down now and start using all this. Go down to example 1. Here we go. This is a review problem. I know it's in the new section notes, but we've already done this kind of thing. 4 to the x minus 2 equals 7. Your job is to solve this equation. What do you think we should do first? Move the 2 over. So 4 to the x equals 9. Now, if this number right here had been a 16, life would be perfect. But it's not. It's a 9. So in order to solve this equation, going to take the logarithm of both sides. And what happens when we take the logarithm of both sides? The exponent becomes a coefficient. So x log 4 equals log 9. And then x equals the log of 9 divided by the log of 4. Now make sure when you type that in, that you close the parentheses that automatically come in. So we have the log of 9 divided by the log of 4. And it's 1.585. If we round to the nearest thousand, which is what we do in AP calculus. Charlie?
What if you like just did the flippy thing?
Exactly.
Okay.
So, no, you're good, you're all good, you're exactly right. So, did everybody follow this? Are you okay? You can do this if you have to, right? Okay. Now Charlie says, let's go back to where we moved the 2, so we had 4 to the x equals 9. That is an exponential equation. What would be the logarithmic equivalent of that equation? The logarithmic equivalent would be what? Log base 4 of 9 equals x. Does everybody agree with that? Now, most of you have that handy dandy button on your calculator where you can just type that in. And that's perfectly okay. So Charlie, that's great. That's absolutely magnificent. You want to convert your exponential into a logarithmic equation, type it in. Now, me, of course, I can't do that because I have, like everything else I own, I have an ancient calculator. So do you remember our change of base? You remember what this is the same as? The log of 9 divided by the log of 4. Isn't that exactly what we did when we used our properties over here? So either way, you need to be able to solve that question. Either way, it's totally fine. All right, let's try B. 2 to the x plus 3 plus 5 equals 26. Now, everybody's going to start the same way. That's the first thing you have to do. We got to move on. So 2 to the x plus 3 equals 21. Now, from this point, you do whatever you want to do. So what are our 2 options? Our 2 options is convert this into the equivalent logarithm equation, So did you subtract 3 and divide by -4? So what are our options again? Let's convert that into logarithms. So that would be log base e of 2.5 equals x. What's log base e? ln. So even I can do that even with my calculator. You could also ln both sides. And so say x equals ln 2.5. So our answer is, did you get 0.916? Okay, the next, those were all exponential equations. Remember, an exponential equation is something to the x power. When you have something to the x power, that's an exponential. Now in part, for example 2, these are logarithmic equations. Sylvia, what do you think we ought to do first? We're on 2A. I would. That's a great idea. And then what might we do, Sylvia?
Divide by 2.
Will?
You just move that up and then switch it, so you have
3 to the third equals x plus 3. It's this thing right here. So 27 equals x plus 3. I'm getting 24 as my answer. Everybody feeling pretty good about that? All right, you and your partner work on B and C. And I want you to come up and put them on the board. Here we go.
What number are you doing? Or letter?
Remember, ln was log base e. Celeste got 13. How's that sound? Okay, good? Good. Okay, now Sam, I didn't read it out loud, but the directions,
Exact form?
yeah,
Oh, wait.
exact form. Okay, so what does exact form mean? Just like in geometry, exact meant leave the by. In here, exact means leave the e. We're not typing this into our calculator to get a decimal. We're just gonna write down what we would type into our calculator. So it is 2 minus e. Okay with everybody? All right, good. Let's see what's next. Example 3. Now we're looking at equations that have more than one logarithm in them. Okay? Now, there are 2 things I want to point out, because Mr. Passwater does 2 things I want to point out before we get started. One is that this does not mean x plus y equals z. You cannot just ignore the logarithms. You can't do it. You are allowed to ignore the logarithms if you have one log equal to another log. Then you are allowed to ignore them. But with multiple logarithms, you got to do the work with the logarithm until you can get it whittled down to this. Okay, got it? Okay, the other thing you have to remember is, remember what your logarithmic equation or picture looked like? Remember, this is what a logarithmic curve looks like? Notice this is y equals log x. Notice what about the x value? Tell me about my domain here. What are the x's? Bigger than 0. When you do a logarithm problem, you gotta make sure that whatever you are logging is positive. We're gonna solve some equations, and we might get some numbers that we have to throw out, extraneous roots, because whatever you're plugging in to take the logarithm of has to end up being positive. Okay, so keep that in the back of your mind. Okay, now let's do it. What are we going to start with problem? Okay. What are we going to do first? What do you think? Charlie,
Well, since they're like added together, we could like, or wait, hold on.
put those together,
Yeah.
and it's going to be the log of 3x plus 12. Beautiful. And then, Charlie, as soon as you do that, then your life is awesome. I mean, it's always awesome, but now it's particularly awesome because we can drop the logarithms. So 3x plus 12 plus 5x minus 2. So 2x equals 15. Did you get x equals 7? Now, all in the habit of going back to the original problem, if I put a 7 in here, this would be positive. And if I put a 7 in here, this would be positive. Okay, now I want to show you something. If we had worked this out and gotten 1 7, we didn't. But if we'd have worked it out and got 1 7, that would be extraneous. Because this would end up being negative. Do you see? So it isn't the x value you have to worry about. It's what you get, it's this guy right here. That's what you have to worry about. Okay, that has to be positive. All right, how about the next one? B. Parker, what are you going to do with this guy?
Divide the x plus 1 and
But we keep the ln, so it's going to be ln plus one over three x minus five equals ln step one. Everybody good? Alright, then we got ln equals ln, so we can resolve our equation. How do I solve that? Yep, multiply the three x minus five to the other side. So x plus one equals 20x minus 35. 20x equals 36. Oh gosh. What is that? 9/5. I'm doing a quick double check. If I plug in 9/5, that's positive. And that would also be positive, so we're good. 9/5 is okay. All right, let's get C and D on the board. Will is done and I do match him. Have a question about that? And Leo, well, you guys might need to get your binoculars out here. Look, Leo got 5. He threw out, what was the other one, -4? Because when he put -4 in right here, this would be negative. Okay, now, once again, I don't want to harp on this, but we're not throwing out the -4 because it's -4. We're throwing out the -4 because when we plug it into the original equation, it makes this negative. If I'd have gotten 2, I'd have had to throw 2 out because that would be negative. Okay, good? All right. Example 4. These look exactly the same to me. So let's just have somebody come up and tackle A and B. I don't see the difference there. So we'll have somebody come up and do 4A and 4 logarithm this does have one little quirky thing. What are you gonna do with that 3 right there? Thank you, Alberto. Who else is gonna come up and give us a shot? Don't make me call on people, it's not as much fun. Alberto got no solution for the first one. How do you feel about that? No solution? And again, negative answers are okay as long as you don't end up taking the logarithm of it.
I got this one.
Right.
I got no solution to it. I look back into it.
Quinn got no solution too for the second one. What do you think about that? Yeah, x can't be negative 7/6. So he is exactly right. And so will you, if that's what you got. What you got? Charles?
Yes.
Any question about either of those two problems? All right. Example 5 is exactly the same problem, but notice how he worded it. Let f be this thing and g be this thing. Find all of the values where f and g intersect. Well, what does that mean, guys? If they're intersecting, then what? They're equal. So it's just a different way of writing an equation like we have been solving. So we'll put these first two together. And since it's ln equals ln, I'll draw them out. What am I going to do now? Multiply by x, so x plus 10 solve this equation. How do I solve an equation that looks like that? Quadratic formula, it's a quadratic equation. You can either complete the square, if you like to do that, or you're gonna use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I got 44 as my discriminant. Is that what you got underneath that? And 44, 2 root 11. And now I got 2's all over the place. So negative 1 plus or minus root 11. Now let's go back and look at our original equation. Doesn't this right here have to be a positive number? Tell me about negative 1 minus the square root of 11. That's negative, so we're gonna get rid of the negative 1, that one's not gonna work. And that's positive, negative 1 plus root 11 is positive, would everybody agree with that? So when I add 10 and add 3, it'll also be positive, so I don't worry about it. That is my answer. Okay? Alright, next one says, got this H and K. What are all the coordinates of the points of intersection? Well, isn't that the same thing? Alright, let's do it. You do it at your seat, I'll do it at the board. Hopefully we match. Don't forget to check for extraneous roots. I got 7/2. This one I factored. You could have done the quadratic formula again, right? It's a quadratic equation, so you're just gonna solve it however you want. All right, now we've got some exponentials. This one is super easy. Super easy. What do we do? Yeah, we just drop the 2's. So clearly 5x minus 1 has to equal 2x plus 7. So 3x equals 8 and x equals 8/3. You do not need to worry about extraneous roots with exponentials, because if you remember what the exponential looks like, What is its domain? Oh, real numbers, right? So there's no extraneous stuff with exponentials. You only have to worry about your extraneous with your logarithms. Okay, well, what are you going to do with b? You are not going to set the exponents equal to each other because the bases aren't the same. Right? So what do you think we ought to do? Make the basis the same, yeah. So let's see what we got. We got an 8 and we have a 2. What do we know about 8? 2 to the third. And then what do we do with this double exponent here? We talked about it very first at the beginning of the period. Multiply. So 9x minus 6 equals x plus 5. Did you get 11 eighths? Beautiful. All right, let's do C and D. We'll have some volunteers up here at the board for problems C and D. See, who hasn't been up here yet? You, Charlie, you haven't been up here yet? All right, yeah, you gotta do one. Who else hasn't been up here? Patrick? Let's go. Oh, wow, they're done already. They got 6 and -1. Okay, I see some of you glancing up at the clock. Just remember, next year, freshmen, sophomores, and juniors, you get to do this for 85 minutes next year. Okay. All right, let's look on the next page, page 4. This is just a continuation. We're going to do the same kind of problems. They might be a little bit harder. Let's see. Example 1. I'm now on the page number 4. Example 1 says, I have this function, and I am going to find the inverse of it. Now, we did this last semester. Gotta remember what our steps are to finding the inverse. You remember?
Well, no, Tracy switched to line there.
Exactly. So I'm gonna rewrite my equation as x equals 3 times 2 to the y plus 4 minus 15. Ultimately, my objective is to solve for y, to get y by itself. So I'm going to just start doing the normal things. I'm going to add the 15. And I'm going to divide by 3. Now, when you do that, and I'm basically saying this because if you look at the answer key, I might have it written one of 2 ways and do the same thing. You might do that by just dividing by 3 and writing it this way. That's fine. You could also do x over 3 plus 5. these are exactly the same thing. Does everybody understand that? And you'll just write it whatever way you want. If it happens to be a multiple choice question, then you have to recognize that these are the same thing. Okay, so I'm just going to stay right here for a second. I know there's more to it, but is that really just a form of this? So one option you have would be to, remember we're solving for y. We have to get y by itself. So we could rewrite this right here as log base 2, right? Of what? X plus 15 over 3 equals y plus 4. Would everybody agree with that? And remember, what's your objective? Solve for y. So all I need to do is subtract the 4. And then I'm going to use the appropriate notation. Instead of calling this y now, I'm going to call it f inverse because it's the inverse of function f. Now, example 2, back up. Example 1 started out as an exponential. Its inverse was a logarithm. Example 2 is starting as a logarithm. So it's starting like this. Its inverse is going to be something like this. All right, I want you and your partner to work on example 2. See if you can both do it and come up with the same answer. And when you finally get your answer, make sure you call it G inverse. G inverse. Basically, you and Annie match.
I got confused, so I haven't finished it yet.
You two match? You think so? Here, this is what I got. Tell me if you match this. We're about out of time. I got 5 to the x plus 6 over negative 3 plus 4 equals the inverse. How does that look? And you may have written this part differently.
X minus 6 over.
Oh, what? Over x minus 6? Yeah, it's supposed to be. Is that all right with everybody?
Yes.
All right. I got a little bit more to do, so no homework's being assigned quite yet, but you certainly can get started on it. Remember, those of you who did not have the review work done for today, get it done. Show it to me.